It's kind of funny, but you know, I sit down and at strangest times when I have opportunities to do so, I'll sit down and I'll just doodle on pieces of paper. So there's one. You can see how sophisticated that is. Once you decide what it is you want to do, you start backwards and just take those pieces and see what kind of configurations you can line up that you actually like. So here it is in a nutshell. We are trying to do the basic layout of the frame. This is going to be the front of one half of the frame. I need an area strong enough to take a hit, so the first thing we build is a triangle. It's kind of good to just get going and get something drawn, and everything will just kind of work itself out, you know, as you go. If you think about it too much, it screws you up. Our goal is to make this frame out of several different sizes, probably 035 chromoly tubing. It's a very lightweight, sturdy frame. I use it on Tazbot dissector. I think we just have a couple more pieces here. This area right here I've reserved for battery space and electronics. This area right here on the top I know is going to fill up full of motor, and I'll probably use this back section right here to put a speed control. You know, it looks a little tight, but this is the middleweight. We're kind of asking a lot for 120 pounds. I think this is looking pretty good. The final step that we do here is we go ahead and mirror the part. And there we go. That is what we are going to try to build today. Now I actually have a drawing. Now this is something that we can print. Now we got our frame. We're going to start adding some parts on it. These are NPC direct drive gearhead motor assemblies. I use them in Tazbot and Dissector. Those are ballistic 24 volt 2.4 amp cell packs, and I'll probably have 2 of those. We'll have a total of about 5 amps in power to run this robot. Should be plenty for the drive system. I'll probably use a separate pack to run the weapons. So now we want to start putting on our wheels. I really like the idea of cambering the wheels. A lot of people ask me that. They say, you know, why do you do that on Tazbot? And I think the main reason is, you know, it's a wider stance, and you know, why put all your energy into having speed and torque going forwards and backwards but not think about left and right? I've also in my design kept the wheels, even though they're cambered, and the framework from extending beyond the wheels, and that's so in case we need to, we can drive inverted. So we started with a sketch, we extrude it, we now worked our way into drawing a jaw. Then I could actually open up the part, go to the other side, and create a left side. So now that I have those 2 jaws, I need 2 more. So again, the part's already made. I just drag them into the assembly, and voila. This is going to be more like a saw blade effect. I got a 24 volt gearhead motor laying inside of here, and 2 carbide tipped saw blades. Okay, so for the third weapon, I'm trying to utilize one of my drive motors to run a very large drill bit that will allow me to wedge underneath another robot and then lift up underneath them and allow the robot to actually drill from the underside. And this is it. This is what you got. You got 2 side catamarans. These points will hopefully go up underneath the other design. And if I have to put some hydraulic assist or maybe some electric actuators to tilt this up, that's what that one in particular would look like. This here is what the whole assembly would look like with this particular weapon in place. The idea is that it would actually pivot in between those 2 catamarans. You can see it from a side profile, that these 2 points would hopefully get underneath the other guy first, and then this point would take over and cause it to jack up and hopefully drill into them against their own weight. One of my favorite designs. So now we take it from here and we head to the garage.